When I have a mathematical relationship in which the variables are all mixed in within the equation and I don't have my dependent variable sorted out on a side by itself equal to the expression in an independent variable, I have to use something called implicit differentiation in order to find my derivative. So if I want to find dy dx, the way that they ask me the question tells me which one's the dependent variable and which one's the independent variable. Here my dependent variable is y and my independent variable is x. So what happens is that whenever I'm differentiating this expression, I need to use my properties of my derivatives, and I also need to make sure that within those properties of derivatives I pay attention to also applying the chain rule when it's needed. And if I have a process of an action on my dependent variable y, I'll need to multiply by the derivative of y with respect to x after it by the chain rule application. So let's look at this particular question. I have two terms on the left-hand side and one term on the right. In my first term, it's the cosine of y. And then in the second term, I have a product of two variable expressions, so I'll need to use the product rule there. And then on the other side of the equal sign, I have a constant times a variable. Now again, with the notation, the d with the letter in the numerator, that's your dependent variable, y, in this problem. And then d with the letter in the denominator, that tells you your independent variable, x, in this problem. So when I'm differentiating the expression and y is the part that I'm differentiating with respect to, I'll need to multiply by dy dx for the chain rule. But if I'm taking the derivative of x, our independent variable, that is just my regular derivative. I won't have the chain rule on those. So here I have my cosine of y. Well, the derivative of cosine of an angle is negative sine the angle, so negative sine y. And y was the variable that we were differentiating the process on, so we need to multiply by dy dx for our chain rule. And then plus, next term I'm going to need to use the product rule. So my first factor is x squared and my second factor is y squared. So my first factor, x squared, times the derivative of my second factor, so that's 2y, but it's y, so dy dx, plus the second factor, y squared, times the derivative of the first factor, times 2x. And I didn't put a dy dx here because it's the independent variable that we were differentiating with respect to. And then equals, the derivative of 5 times y is 5, but it was the y letter, so we multiply by dy dx for our chain rule application. Okay, now let's rewrite these terms also. They're a little bit more comfortable to work with, and then we'll solve for dy dx. So I have negative sine y dy dx plus, here it's all multiplication and multiplication's commutative. So I'm going to change the order and write this as 2x squared y dy dx. And then plus, in this term we again want to rewrite it as 2xy squared. And then on my right hand side I have 5 dy dx. Now to solve for dy dx, the first thing you want to do is to sort your terms. You want all the terms that have dy dx on one side of the equation and all the terms that don't have dy dx on the other side. So this first term, this has a dy dx. The second term has a dy dx. This third term on the left-hand side does not have a dy dx. On the other side of the equal sign, my term 5 dy dx has a dy dx. So what I want to do is I want to subtract the 5 dy dx to the side where all the other terms have the dy dx in them. And I want to subtract this 2xy squared to go on the right side to be where the terms are that don't have the dy dx. So we have negative sine y dy dx plus 2x squared y dy dx minus 5 dy dx equals negative 2xy squared. Now factor out, you've created in all of these terms a common factor of dy dx. That's why we sorted them this way. So we can factor out our common factor of dy dx.
So dy dx gets factored out. I'll have a negative sine y plus a 2x squared y minus a 5 is equal to negative 2xy squared. And what that allows us to do now, since it's dy dx times that entire expression, we can just divide both sides by negative sine y plus 2x squared y minus 5 to solve for dy dx. So dy dx in this problem is my negative 2xy squared divided by my minus sine y plus 2x squared y minus 5.